In October 2025, Google's most advanced quantum processor, a chip the size of a thumbnail, did something no one anticipated. It sent a signal into the quantum realm and then reversed the process to check for errors. What came back, shockingly, was a pattern. Structured, repeating, growing stronger every single time they tested it. But here is what nobody is saying out loud. That exact behavior, a structured signal, was recorded 126 years ago by Nikola Tesla. He had no quantum computer, just copper coils and a metal tower. And what he detected that night terrified him so deeply that he spent the rest of his life trying to understand it. And what he heard in 1899 may be the same thing Google just heard in 2025. Today, we are going to connect those two moments, because when you place them side by side, the match is specific, and it raises a question that neither century has been able to answer. What exactly is responding? The 2025 anomaly. In October 2025, something happened inside a secure laboratory at Google that shocked every scientist who witnessed it. A quantum chip, Willow performed an action no one believed was possible.
The latest development from Google that it describes as a state-of-the-art quantum computer chip.
The chip acted as if it was listening. It behaved as if something in the dark layers of physical reality had whispered back. The event began with a simple test meant to study how the chip handled errors. Yet it unfolded into one of the most disturbing scientific anomalies ever recorded. The experiment was supposed to be routine. Google's team sent a small burst of microwave energy called a pulse into the quantum realm through the control lines that operate the chip's qubits. The quantum realm is the world of extremely small particles, such as electrons, that behave in ways normal physics cannot easily predict. The team wanted to see how this pulse moved through the chip's 105 qubits. They expected it to fade away, which is what normally happens when quantum information breaks down in a process called decoherence. Instead, something impossible occurred. After sending the pulse, the scientists reversed the entire process. They attempted to run the system backward to check for errors. When they listened for what returned, they did not hear a fading, dying signal. They heard a pattern growing stronger, waves built upon waves in a way that looked like sonar inside a dark and bottomless ocean. The returning signal rose in strength, as if something was feeding energy into it. This made no sense, because in a closed quantum system, a reverse signal should shrink instantly and vanish.
You've got some system that's sort of just out of reach of what a classical computer to do, but a quantum computer can kind of just put you past it.
Then the chip started behaving in a way that had no explanation. It began showing what scientists call non-Markovian behavior. In simple terms, a normal quantum system has no memory. Every state it enters is fresh, with no connection to states it never actually passed through. But Willow started behaving as if it remembered states it had never been in. It was acting on information it had never received. This is not a minor technical quirk. It is the kind of behavior associated with systems that are pulling information from somewhere outside their own history, somewhere they should have no access to. The waveform that returned did not simply grow stronger. It came back with phase alignment, meaning the waves were moving in perfect step with each other, reinforcing instead of canceling. A few researchers suggested internal feedback might be responsible, but the pattern did not match any known behavior of the chip. Some qubits showed activity before the pulse even reached them. This is called retrocausal behavior.